All right. Let's see. 2 weeks ago, ooh, I have an echo now. No, I don't. 2 weeks ago, we ran into this problem number 7.
Yeah.
I really didn't think about hard enough. It's not a hard problem. It's just that you kind of have to think out of the box a little bit.
Okay.
Okay. Now, let me expand it a little bit so I've got some room, some white to write on. And first of all, we don't know the function. Because all we have been given is 4 data points. We know that when x is 0, f of x is 3.
Mm-hmm.
So if I want to draw, there's one data point, 0, 3. Another data point, when x is 2, f of x is 1. And a third data point, when x is 4, f of x is 0. And finally, the last data point, when f of x is 5, f of x is -2. This is the key point right here. Now, I can connect those dots if you like. It appears to be a straight line. That's fine. But what do we know? I mean, even if this was a curved line, what would we know one of the factors has to be based on that point right there?
2?
X minus 4.
Oh, okay.
Let me put it another way. If I gave you a more complicated polynomial, something like that, and that point is -3, this point is 1, and this point is 4, what are my 3 zeros?
Why?
What are my 3 zeros? Where on the x-axis do the 3 zeros appear? This is the x-axis. This is the f of x-axis. So what 3 numbers do are the x-intercepts at?
-3, 1, and 4.
Yeah. And what that tells me for sure is that I have a factor at x minus 1 of the intercepts. I have a factor at x minus 1 of the other intercepts. And I have a factor at x minus the first intercept. So the one thing I know about that polynomial is it has those 3 factors. It might be a 5/5 term polynomial, in which case it could have a couple imaginary factors also, but for sure I know it has these 3 linear factors. So the thing to remember is that no matter what the curve looks like, whether it's a straight line or whether it is a parabola like that, these 2 points, whatever the x value of those are, has to be a factor. Well, in this particular function they're giving us, we don't know whether it's a linear, quadratic, cubic, whatever. Could be any of them. We don't really care. The point we want to find is where f of x is equal to 0. That comes when x is 4. That means x minus 4 has to be one of the factors.
That's really not a problem at all.
No, it's not that hard. You just have to think about it correctly. In other words, it's one of those problems that I wasn't thinking graphically the first time I came across it. The moment I gave a little more thought to it and started thinking that probably the first way to go about solving this would be to graph those 4 points and see what you're looking at. And then I realized that the factors come from the x-intercepts. That's what makes something a factor of a polynomial.
Okay.
Is
Okay.
x-intercept. All right, let me look in my to see where we left off. Number 9 that day. Okay, let's go back and go back to 10. Now, next week,
Yeah.
let's plan on doing a little bit of non-math.
Okay.
I am going to be giving a presentation on SAT, PSAT, all 4 topics, the reading, writing, math, and the other one they have, or all 3 topics. And it'd be a good time for us to cover it. Would either be next week or the week after, and both if you feel it's valuable.
Okay.
It really kind of depends on whether you're going to want to cover math or the others, more importantly. You may feel we're really confident in the others and I won't have much to lend, but I can certainly take you through some key points that I think you'll find valuable on the reading and writing.
Shortcuts and things like that?
What's that?
Well, kind of like shortcuts and things like that?
Yeah, just some tips. What I do is a 5-hour presentation, a PowerPoint presentation for students, the classrooms. And you don't do one-on-one tutoring, but we do give you some overall general tips in all of the subjects, not just the math. And I'm happy to share some of those with you. Like I said, we can go through it really fast, but I got a feeling it would be worth at least one of our sessions to go through that quickly. We can probably do my whole 5-hour, if I don't include the math, we can probably do my 5-hour presentation in an hour. Because a lot of that 5 hours is having the students take practice tests, which I won't do. So in an hour, I bet I can cover most of the points that you'd want to know about. The key points in the non-math end.
Yeah, right. Okay.
Today, let's continue on with math. We finished number 9, so let's have a look at 10. Well, these get hard quick, don't they?
Yeah. Okay.
Now let's figure out how to graph that. What's the parent function?
X minus 11.
No. The parent function is y equal x squared.
Okay, so can you explain that to me?
Well, there are 10 basic parent functions. Okay, I'll list a few of them over here. This is the linear one. This is the quadratic one. This is the cubic one. This is the square root function. This is the logarithmic function. This is the sine function. This is the cosine function. They want you to know what all of these look like. And there's 10 of them. I've only listed 7 of them.
Okay.
Okay. This one is a straight line. This one is a parabola that goes through the origin. So when I look at the function they've given us, it's not y equal x squared, it's y equal x minus some number squared.
Okay, yeah.
So if I draw the parent function on here, now what transformation is that? How can I graph y equal x minus 11 squared? Remember your transformations. Is this a vertical or a horizontal transformation?
Horizontal?
By how many and which way?
11 to the right.
Good. So, all I'm going to do is move my vertex there. And that is y equal x minus 11 squared. So, part 1 is done. Here, let me erase some of the stuff we don't need. We don't really need the parent function on there. Only reason I put it on there is because you can't really get to how you graph this function without knowing what that parent function looks like. Now, how do I graph this function? Y equals 25.
That's going to be a vertical transformation?
No, but you're half right. Is that a horizontal line or a vertical line?
Horizontal?
Where?
Like the blue at the bottom?
Horizontal going through what point on the y-axis? Uh-huh, 25. In other words, what it says is y equals 25 no matter what x is equal to. X can be 0, y is equal to 25. X can be 100, y is equal to 25. X can be 1,000,000, y is equal to 25. That's a horizontal line. Okay?
Okay.
Okay, so second part of the problem done. Now, the question is what is the distance between that point there, A, intersects at 2 points, A and B. What is that distance? Well, how do I figure out where those points are? If I can figure out where those points are, then figuring out the distance won't be hard. It's a horizontal line, and I just take the difference between the x coordinates.
Oh.
So how do I know where point A is? When you're looking at two functions graphed, and you're trying to figure out where they intersect, what do? You set them equal to one another.
Okay.
Here's our two simultaneous equations. Y equals 25 and y equals x minus 11 squared. Okay, if I want to solve that to figure out where they intersect, well, this y is the same as that y. Certainly at this point A it is, and at point B it is. So I'm going to set that equal to that. So I've got 25 equals x minus 11 squared. How do I solve that equation?
What's that?
How do I solve that equation? 20
Rid
equals.
of this. Yeah. So to solve for x, you on the right side of the equation with x minus 11 and then the parentheses and the squared, you can multiply that by 1/2.
Not 1/2. Square root.
Are you dividing by 1/2?
Square root both sides.
Oh, right.
In other words, if I take the square root of that and the square root of that, the left is plus or minus 5, not just 5, plus or minus 5. The right is x minus 11, because the square root of something squared is just whatever that something was. And now I can figure out what these 2 points are. In other words, if I solve this equation further, I get x is 16, or x is, let's see, I'm adding 11, 6. In other words, I'm solving this equation right there. So I'm adding 11 to plus 5, which gives me 16, and I'm adding 11 to minus 5, which gives me plus 6. What's the distance between A and B?
$16.
Okay, this x-coordinate is 6. This x-coordinate is 16.
Oh, 10.
Now notice how many different math principles we had to cover to solve this problem. Now, was there a quick and dirty method of doing it? I don't think so. No. In other words, if they'd have said, give me one of the points, A or B, then I could have gone through all their answers and plugged it in and see if it matched that equation. But they didn't ask that. They wanted the length of A to B, which means we have to figure out where A and B occur and then subtract the 2 numbers, which is significantly different. This is not a problem that lends itself to back solving, because they're not asking for a single thing, an entity like where is A or where is B. They're asking for the difference between A and B. And that makes all the difference in the world. You can't really use back solving when they ask you for a combined thing like that.
Okay.
Back solving is where they ask you a single thing that you can plug it in and check your answers. All right, let's do a geometry problem. Now, I am going to cover up the answers because this is not the kind of problem where multiple choice helps. What you have to determine is 1 true, is 2 true, is 3 true? And then we'll look at the answers and figure out. In other words, we've got to do this problem without assistance of the multiple choice.
This is 11, right?
Yeah.
Okay.
So I've covered everything up except the 3 things we have to answer. Now, let's read the premise. Again, I really do not believe this is a sample test. What this is what they believe is the sample perfect practice test. In other words, every problem you have to know 4 different math principles. That's not probably going to be true on the regular. It might be true on the harder problems. But on the easier problems or the medium problems, you may only have to know 1 or 2 math principles to get the thing right. All right? So let's look at what we're looking at here. First of all, the figure is not drawn to scale, meaning we cannot assume that x is equal to y is equal to z. they do tell us that x plus y is equal to u plus w. So here, let me draw that information on there. X plus y, this angle right there, is equal to u plus w, this angle right here. What can you determine from that? First of all, tell me if there's any relationships between x, y, u, and w that you already know.
U and Y are vertex angles.
Correct. So y is equal to u for sure. And if x plus y equals u plus w, and y is equal to u, what's the relationship between x and w?
They're equal to each other too?
Correct. So we know that x equals w. So we actually know those two things for sure. So let's put numbers here. We know that's angle 1. That's angle, we'll call this angle 2, we'll call this angle 3, we'll call this angle 4, angle 5, angle 6. So we know 1 is equal to 4. We know 2 is equal to 5. What about 3 and 6?
They should be equal to each other too.
Exactly. They do have to be equal to each other also. So we got z has to be equal to t. Okay, so is x equal to z?
Yes.
No. Sometimes the best way to solve these problems is by graphically seeing it. And I'll show you why that's not true. If I drew my line like they have it, where they're all relatively equal, 1, 2, 3, and we know that 1's equal to 4, 2's equal to 5, 3's equal to 6, but is 1 equal to 3? Well, all I have to do is slant this line slightly so that it looks like this. Now 2 would still be equal to 5, but 1 would not be equal to 4 anymore. So much for that idea. I thought that was going to tell me something. Here, let me look at this a little bit more. So this is question mark. We don't know yet about that. Is y equal to w? We know 2 is equal to 5, but we don't know that 2 is equal to 4.
Yeah.
So that's a question mark. And is z equal to t? Yeah, we know that for sure.
Yeah.
Now, could I draw this picture in a way that these were not all 60-degree angles? Let me try. I know how to draw it using all 60-degree angles.
Can I ask you something real quick too?
Uh-huh.
So since we know y and u are equal to each other, so that would mean z and w and x and t are equal to each other, right?
Well, c is equal to w because they're vertical angles.
Right.
And 1 is equal to 6 because they're vertical angles.
Yeah. Okay, that's what I thought. Yeah.
Okay. So we do know all of that. But here I've drawn the picture. In other words, if all 6 of these angles were 60-degree angles, then all 3 of these statements would be true. Now the question is, do they have to be 60-degree angles? Well, I just drew a picture where they're not, and yet all of their statements are true. K plus y, in other words, that plus that is equal to this plus this. In other words, all of their premises are true here, but 1 is not equal to 3. So I don't think you can say x is equal to z. I can draw it in a way that x is not equal to z. 1 is not equal to 3 in the way I've drawn it here. I don't think. Hold on, maybe it is. You know what, actually it is. What isn't true is that 1 is not equal to 2. You see the way I've drawn this?
Yeah.
This is 1. 2 actually goes all the way across. That's 2, and that's 3. And if I slant these just a little bit so that they go like that and like that, now none of them have to be equal to any of them. In other words, all I took my 2 diagonal lines and I rotated it so that 1 was not equal to 3. And 1 was never necessarily equal to 2. So I think we're, excuse me, allergies or something. An annoying cough. So this is definitely not true. Y equals W is not true. Z equals T is not true. Notice that if I take those 2 lines and if they were chopsticks and I just rotated them a little bit by 5 degrees, then Z would not be equal to T, correct?
Yeah.
And yet Y would still be equal to U, X plus Y would still be equal to X plus U, and so forth and so on. So Z doesn't have to be equal to T. So I don't think any of them are necessarily true. And that's what it says. Which of the following has to be true? Now, one could choose to solve this algebraically and set up a bunch of simultaneous equations which you wouldn't be able to solve. Or you can try to solve it graphically like I did. Obviously, the way I solved it was wrong because that's not one of the answers. None. It's another one I'm going to have to get back on. Obviously, 2 out of the 3 are true. Since all the answers have at least...
You would say they're correct.
Yeah. So, if I only had a few seconds to go on this test and I had to answer an answer, it would be this one right there. It would be D.
E?
it'd be D. In other words, I think all three of them are true. If they're telling me that 2 out of the 3 have to be true, I'd have to give this a lot more thought, which obviously you don't have when you take this test. You only have 2 minutes of problem. And
Right.
I don't know that I can answer this in 2 minutes, even if I was taking the test.
Is it at all possible that it's like being overthought?
Yes, it is. In other words, the easiest thing to assume is that that's a 60-degree angle. Here, let me rewrite. The easiest thing to assume is that that's 60. That's 60. That's 60. That makes up 180. That's got to be 60, 60, and 60. Now, both of their premises would be true. That's true. 120 is equal to 120. And all three of them would be true. Z is equal to T. I'm just not sure that all three of them are true. I'm pretty sure I can draw this picture in such a way where the third one is not true. Which one would that be? Y is not equal to W. That's the one I would say is not true. So I would say 1 and 3 would be the answer.
Okay.
Here's why I think we can do that. Let me try to do it real quickly. If I take line K and I tilt it just a few degrees like that, and I take line L and I tilt it just a few degrees like that instead of where it's at, well now, and let's change these measurements. Let's make that 40. Let's make that 40. Let's make that 100. 40, 100, and 40. Okay, that picture makes sense. It satisfies that. 140 equals 140. And yet we see that X is equal to Z, true. Y is not, 100 is not equal to W, which is 40, so that's not true. But Z is equal to T, 40 is equal to 40. So I know those two are true, and I know that the middle one is false, merely by drawing it this way.
Okay.
And this is kind of like the old adage that if you're trying to prove something is not correct, you only have to come up with one way to prove it's not correct. If you can come up with one triangle in the whole wide world that does not satisfy the Pythagorean theorem, then you've disproved the Pythagorean theorem. Now, for me to prove the Pythagorean theorem, I could give you a million examples that fit the Pythagorean theorem, and that still does not prove it. So proving something is a whole lot harder than disproving it. But to disprove it is all you have to do is come up with one case. And I absolutely did here. I came up with one way to draw this thing that made Y not equal to W. And that's what proposition 2 says, is that Y is equal to W.
Because the key fact would be to note that the figure is not drawn to scale, so in fact you cannot assume that all three would be 60.
Well, exactly. In other words, yeah, not drawn. In other words, if you look at it as drawn to scale, each of those angles is 60 degrees. They're pretty close. And that's the key, is they don't have to each be 60 degrees. So that's kind of a clue as to how to solve the problem. Let's see if we can draw it a different way that still satisfies the only premise they've really given us, which is that one right there. X plus Y has to equal U plus W. All right. Let's go on, see if we can find something a little easier. Wow.
Would that be one to come back to the very end of the test and put 3 check marks on?
Well, any problem you encounter, here's the way you're going to do this test. You're going to do, well, yeah, you're going to plan on going through it at least twice. You're going to look at all 60 problems when you still have time left to go through and do the ones you put a check mark by. Now, how many that is, really the way to do it is if you know how to do a problem the first time through, do it. If you don't know how to do it, put a check mark by it. And then say you look at all 60 problems with 10 minutes to go. Now you go back and maybe instead of using just a single check mark, the medium ones you put a check mark and the hard ones you put a double check mark. So the second time you go through the test, you're going to do all your single check marks, the medium ones. And in fact, at that point in time, if you realize there's no way you're going to have time to get to the hard problems, go ahead and guess the second time through on the hard problems. In fact, if a problem is really, really hard, and you just know for sure you're going to end up guessing on it, guess on it the first time through so that it doesn't take up 3 seconds of your time when you're making sure. In other words, the one general rule is never leave an answer unanswered. Never leave a question unanswered. That is the golden rule in taking these tests. Ever, 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 never leave one unanswered. Always guess. There's no penalty for guessing, and you stand a 1 in 4 chance of getting it right. So the worst cardinal sin is to run out of time before you've guessed on everything. And the best way to do that is with that system, I think, where you answer the first time through everything you know how to answer, whether you're certain of it or not. If you know how to do the problem, give it a shot and answer it. And then the medium ones you're not sure if you know how to do, put a single check mark by. The really, really hard ones that you're pretty sure you don't know how to do, put a double check mark by and or guess at that point in time, the first time through. Guess on those. But always leave yourself with enough time where you can go back and at least give some time to those medium problems.
Okay.
That was number 11. So let's go to 12. The only thing I know about this problem is that it's not a one-step problem. I haven't even looked at it yet. Just given all the problems we've encountered up until now, we're going to have to know a lot to figure out this problem. All right. So, whoops, hold on. What's the first thing we should do?
Graph it?
What do we know about it to allow us to graph it? What are really the 2 pieces of information they've given us that tell us where that thing has got to go through?
We know where the x-intercepts are.
Okay, where are they?
2 and negative 4.
There's one of them at 2. Here's another one at negative 4. We know it's a quadratic, which means it's a parabola. We don't know if A is positive or negative. It just says A is non-zero constant. So either the thing looks like this, or it looks like this, or it could even look something like this. In other words, a skinnier parabola that goes through those same intercepts. And depending on what A is, we get one of these curves. there are literally an infinite number of curves that would all be parabolas. They would all go through those intercepts. Okay, now the vertex is at C comma D. What's the vertex format for a parabola?
Oh, I do not remember the equation.
This is the most important one to remember. There's actually two. This is the
Okay.
X-Intercept format. Here's the vertex format. Believe it or not, those A's are the same. Okay? They tell me that my vertex is at C, comma, D. Well, in vertex format, what does that give me? What is H?
What is what?
What are H and K?
The X and Y intercepts.
Not the intercepts.
Oh,
They're the vertex.
yeah.
And they're telling us the vertex comes at CD. So this equation is x minus c squared plus d. So this equation number one is the same exact as that equation number two. It's just this one, number one, is in y or x-intercept format. And this equation is in vertex format. And each format has its advantages and disadvantages. Usually the most important part of a parabola is its vertex. So vertex format is the first one they really teach you, because knowing where the vertex is the most important thing for drawing that parabola. But the x-intercept is the second most important thing, because you got to know where your x-intercepts are to know where it crosses the x-axis. Now, since those two are the same equations, this y is the same as this y, and that a is the same. So, we'll set one equation equal to the other. We can divide a out. So now we have x minus 2 times x plus 4 equals x minus c squared plus d. They want to know which of the following is equal to d. Well, so all we got to do is solve that equation for d. It's actually relatively easy. And let's start with what we have. X minus 2 times x plus 4 equals x minus c squared plus d. What's the next step? If I'm trying to solve d, notice all my answers are in terms of a. Why is that? Let's go ahead and put our a back in there. Those are both the same a, but it doesn't necessarily follow. Just do something here. So if I do cancel the a's out, I get this. And I get d equals 2x minus 8 plus 2xc minus c squared. That's what I get for d. Now, how are they getting all of those variables to go away? Here's what I think they're doing. Yeah, we got just about enough time to finish this. If I start with this, okay, I know those two equations have to be equal to one another. I don't know that the a's are necessarily the same a, but let's just see what happens here. If I multiply those two linear equations together and distribute the a, I get ax squared plus a times 2x minus 8a on the left side. Right side, I get ax squared. See, normally I would have minus 2xc, so I get minus a 2xc plus c squared plus d. Now, I can definitely do this. And I get d equals a2x minus 8a divided by negative a2xc plus c squared. I know there's an a in front of that also. Just left it out. Now the a's all cancel. You get 2x minus 8 over 2xc plus c squared. Well, that's enough time spent on this problem, I guess, since I can't figure this one out either. Let's go on. Now, all of these have been non-calculator, is that correct? Yeah. I guess I'm going to have to look at this in advance. I had no idea these were so hard. Let me just take a look at 13. The reason x cannot be equal to 2 over a is because you would be dividing by 0. So this is not really a critical part of the problem. It's just the way math problems are always presented to you. They always restrict you from dividing by 0. So we're not really going to use that in our solution unless our solution comes out to be that. and then we'll have a problem. But let's just try to solve that. It's a hard algebra problem, but not as hard as it might look. What's a real easy first step that would simplify the problem immensely? What's one of the first rules in solving equations?
What you do to one side, you gotta do to the other.
Well, get rid of your denominators.
That's what, yeah. I was gonna
Really complicated denominator there. How can we get rid of it?
multiply by it.
Both sides by it.
Yep.
Okay. So here's what we get when we multiply both sides by it. I'm going to do over here on the left side is easy. Just becomes the numerator. The right side is a little tricky because notice that I got to multiply both terms by ax minus 2. Well, it's going to take care of that denominator in the second term, but the first term, I got to multiply all of that by ax minus 2. Well, if I do that, minus 8x minus 3 times ax minus 2, just FOIL it, I'll do it. That's minus 8ax squared plus 16x minus 3ax plus 6. Minus 53. See where we get the minus 53? Okay, so that's what I'm going to do is I'm going to add that 53 against that 6. So I'm going to end up with this. 8ax squared plus 16x minus 3ax plus 6 minus 53 is minus 47. Now, we can solve it. What does minus 8a have to equal?
Uh,
47's cancel. Equate coefficients. In other words, the coefficient of the x squared on the left has to be the same as the coefficient of the x squared on the right.
Okay.
Say 24 has to equal minus 8a. And that allows us to solve for a. Minus 3.
That is gross.
It is gross. It is a principle. Usually you don't really learn until you get to partial fractions in calculus, but when you have one quadratic equal to another quadratic, and you're looking at an x squared term, an x term, and a constant on both sides, then you can equate coefficients. That is a legitimate technique. In other words, that coefficient has to be equal to that coefficient. What does 25 have to be equal to? Well, if I factor out an x here, I get an x times its coefficient, 16 minus 3a. So I could also say 25 has to be equal to 16 minus 3a. And that will also give me the answer of minus 3 for a. But this technique of equating coefficients is one that you occasionally will have to use. I'm not sure that's the hardest part of this problem. The hardest part of this problem may be, what's another way you could do this problem? So that it's not so gross. Real simple. What's the first fallback? If you don't know how to do a problem, check what whether you can do something.
Like terms?
Can I back solve it? Can I back solve it? In
Yeah.
other words, I'm never going to start with 16. I'm always going to start with B or C. If I plug in, say, 3 for A, is that equation equal to this equation? That's not hard to figure out. If I use 3 for A, I'll be able to determine that in a couple steps, and I'll discover that no, it doesn't work there. So let's try -3. And when I try -3, it'll work. This equation will be identical to this equation if you use -3 for A. And that would be a lot easier way to solve it. Don't you agree?
Yeah, that'd be a lot faster.
Yeah, the first way was gross. I didn't even think about it. I should have. The math, there's still a lot of arithmetic, and you're not allowed to use the calculator, so I'm not sure it makes it all that much simpler. Whereas the method that I did that was gross, I didn't need a calculator.
Right.
I'm not sure you need a calculator here if you use small numbers for A. In other words, I definitely would not need a calculator to try B or C as answers.
No.
If I want to try -16 as an answer, even that, the only place we're substituting is there and there. So it shouldn't be that hard to do with any of those. So moral of that story is always check to see if you can back solve a problem. And if you can, it's probably the easier way to do it.
Makes sense, yeah.
All right, Ben. Boy, these were tough. I cannot ever say I've ever come across 4 or 5 more tough problems than what we did today.
Oh, really?
Ridiculous, yeah.
Yeah. Good practice, though. I mean.
Well, I suppose it is. I don't know. It may not be the best practice. Because these problems may be problems you put a double check mark by, and you're going to end up guessing on them anyway, so why are we spending all this time covering them? So
Yeah.
that's always been my philosophy, and that we're probably better off covering beginning and medium problems. So maybe we need to go back to that method, whereas when we come across a problem like this, we'll just skip to the next test and do the first 5 or 10 on each test. And that way,
Yeah.
we can stay in the problems that are the most useful for you to review. It doesn't really do you a lot of good to review something this difficult. If you're not going to be able to do it on the test, it's just a waste of time.
Yeah. Better use of time just to do it the other way.
Yeah, I'll go back and I'll start. I should have done that today. I didn't realize how hard these were going to get this quickly. All right, Ben, I will talk to you next Saturday, and we'll plan on covering a little bit of reading and writing.
Okay, cool. Yeah, that'll work.
All right, bye-bye.